Welcome to the third workshop run by ECA and Josh in particular. And this one is on data visualization. So as per usual, we will have, I think Anna has been given the title of Chat Concierge. So she will be your concierge in the chat room if there are any questions. We do have quite a lot to get through, so Josh has inserted some slides where we can stop and have some question time. But I will hand over to Josh. Thank you.
Awesome. Thanks so much, Jackie. Bear with me. Before we begin, I'd just like to acknowledge the traditional custodians of the lands in which the Bonet Institute is located, which is the Wirrawong and Boonwurrung people of the Kulin Nation. I'd also like to acknowledge the traditional custodians of the lands where I'm currently located, which is the Jagera Turrbal people, and pay my respects to their elders past, present and emerging. Before we begin, I'd also like to welcome our superstar data scientist, Mar Quiroga, who will be joining us today, answering questions and helping us to dissect some graphs and look at some graph theory and some data visualization techniques. So Mar worked at the Burnett, but recently left to join Melbourne University. And she now, well, Mar, would you like to introduce yourself and say what you're currently up to?
Yeah, sure. I'm currently a research data specialist at the Melbourne Data Analytics Platform. And so it's a centrally funded platform where we get farmed out to collaborate with researchers from any domain in the university. They bring the domain expertise and the research question, and we help with the technical aspects of it, whether implement an algorithm or implement a machine learning model, or maybe use high performance computing, or whatever it is that technically is needed for the research question, but maybe the researchers don't have that technical expertise. So that's what I'm up to now. And I'm very, very happy to be here.
And we're happy to have you. Feel very lucky. Awesome. Cool. Let's move on. So I'm just going to do a couple of slides, just doing a brief overview of data visualization and some of the kind of basic theories around it. So data visualization is about kind of bringing together a lot of different information and data and different types of figures and charts in order to create a single kind of presentation of data. So at a good data visualization, the first rule is really to focus the reader's attention on the data that is most relevant to the question that you're answering, in a way where it starts to tell a story and creates a call to action. So we'll go through that in a couple of slides, but really it's just around making sure that it's not just a bunch of information just plopped on a chart. It's actually got a kind of a narrative to it, and it actually creates a kind of story in the reader's mind. And I'd like to just sort of touch on the fact that don't feel confined to the same kind of bar charts that you're used to seeing all the time. A lot of really good data visualization can include different text and different shades and different gradients and different things that can really make the figure pop. So matching a figure to your story. So yeah, so this is really around asking yourself, what's the question that my figure is trying to answer? How is it fitting into the kind of broader narrative of the piece of work that I'm doing and the kind of research question that I'm asking? And then how is it answering that question, and is it answering the question in the way that I want it to? So this can be done using lots of different strategies and different chart types. And it can be used to show how data is composed, to make comparisons between different groups and different variables, to show relationships between variables or how a variable changes over time, and to show how a variable is distributed within your data, or groups are distributed. So we're going to start with a very short data visualization exercise, which the aim of this exercise is to be able to allow people to see how just using some simple data visualization techniques can draw the reader's attention to the most relevant parts of the figure and the data that's most relevant. So we'll start here. If everyone could just try and count in their heads the number of A's that are in the following figure, and then just take into account how long that's taking you and the kind of cognitive processes that you need to find the A's. All right, that's probably enough time. So Well, I think the first thing that, well, hopefully the first thought that you've had is that the A's are quite difficult to find in this figure. They get kind of lost. You kind of have to scan it. It's hard to do it in an ordered sequential way. It's really hard to focus your attention. And then if you were to present something like this in a manuscript or in a report, it's very easy that readers will completely lose interest and not get the information out of it that you want. In this next slide, what I've done is I've just changed it so that there's a contrast between the A's and the rest of the letters. And this highlights the A's to the reader and helps draw their attention to what's relevant in this figure. And then here I've gone one step further and I've added, I've made the A's larger and I've made them red to further emphasize the information that I'm trying to draw the reader's attention to. This is a really good technique, but also need to be mindful of the fact that too much editing and too much color can actually make stuff more complex and messy. Cool. So I've put in a slide here so we can pause for Q&A. So Jackie, have you got any questions for Mar or myself that you'd like to ask?
I have a really stupid question.
No such thing, Jackie.
Yeah, no, but if you go back to that question, Josh, I get that you're identifying you're identifying what you want the reader to see, but isn't it the reader's responsibility to see? So it's quite leading. Do you understand what I'm trying to say? I'm a qualitative researcher, so we're talking about, leading and you can ask any question and get the answer you want. Are you leading me? Are you telling me the story you want me to see? Wow, I'm really,
that's a great
really
question.
Impressed with how much I nailed that.
Mar, would you like to answer that one, or do you want me to have a crack?
I mean, sure. I mean, yes, exactly, precisely. That is what we're doing. We're telling you from this figure, what is it that we want you to see there? What is it that we want you to take away from it? The task here, of course, this is a toy example. So the task here was to count how many A's, and you just want, I want to make that as easy as possible for you to do. Of course, it's a little bit more complex when you're presenting scientific figures. You have to be fair to what it is that you're showing, right? Or results from something. But I think it's a brilliant question. Yes, you do have the power to define what other people will see in these things, but you have to be fair. You have to be just. It has to be something that's actually there. You don't want to show something that's not there.
Not there. No, that's right. That's right.
I think that is a really good question though, Jackie, because it's the same as when you teach kids about advertising and that, it's balanced, and in some things the balance is in favor of the advertising. They lead people in a certain direction, and then we don't tell people we're leading them in that direction. So what we are actually showing you is the techniques for you to be able to understand when you are being led, why, and critique that. So I think you're right. We could expand on Josh's, very simple example is actually very powerful, because it's not just showing you how that's done, it's then embedding the tools and the knowledge for you to say, well, is that right?
Yeah.
Not only just how have they done it, but is that the right thing that they should have done? Does that actually tell me the information that I should be seeing? Or is that telling me something that they want me to see and they're hiding something else? So what we're giving you today is the techniques for you to lead people, but also to critique when you are being led.
Yeah, that's great. Welcome, Melita. Welcome, Bianca. We've just gone through the basics here, and I've just got Veronica, I think, joining as well. So any other questions? Josh, we might keep ploughing through.
Let's crack on. Awesome. Pardon me, I went backwards. Cool. So just going to go through 6 different examples of some charts that can be used in different circumstances to answer different questions. So I'm going to start with two different examples of charts. This isn't an exhaustive list. This is just some kind of basic examples. But this is how you can show breakdowns within groups. The first is the very popular pie chart, which is very useful for showing how data is split between groups, or between groups for one variable. It's very basic and straightforward. You tend to just have a single kind of group that you're looking at. Some basic kind of rules to make sure that you're always following are that the sections of the chart add up to 100% and that the groups are independent of each other. So you don't have, the groups are independent of each other and they're all part of the denominator. The second chart on the right, we've got stacked bar and column charts. So this is how to kind of take this kind of principles of the pie chart and add another layer of complexity. So in this case, we're looking at age groups that are attending appointments at this clinic by month. So now we've added this time component to it, but we're still able to show the breakdown within groups for each month. There's value in adding this kind of level of complexity, but then it also, as you can see, starts to become a little bit too complex and difficult to interpret as the sizes of the bars, of the stacks in the bars are kind of hard to compare between different months. So it's just kind of being mindful about the simple versus presenting more information balance and trade-off that you always have when you're doing figures. Next, we've got making comparisons between groups. So you've got this on the left-hand side, we've got our side-by-side bar charts. So this is good for making comparisons between groups. And so in this case, I've got a similar thing. We've got it, but for men and women by month. So for me as the reader, when I look at this graph, what I'm doing is for each month, I'm making a comparison between men and women because the men and women are next to each other in the months, which is, depends on your question, but that could be the way that you want to go. And then we could also see that the percent of appointments attended has been increasing for women, and for men it's been decreasing, and it's created this kind of disparity by June. So this can be done for these proportions as done in this figure, or you could also do it as absolute or raw numbers if you like. On the right-hand side, we've got the side-by-side line charts. This is the same data but presented as a line chart. And it also is doing a nice job of showing how the proportion of appointments attended is starting to diverge around June. So this is also very useful for showing how groups differ over time as well. If we want to show relationships between two variables, this is kind of a rabbit hole of charts really. But on the left-hand side, we've got the tried and true, which is a scatter plot. So scatter plots are very useful if you're trying to make a comparison, show a relationship between two variables that are both continuous. So in this graph, we've got days. By the way, I should clarify, all of the data that I'm presenting, I completely made up in Excel myself, just randomly punching in numbers. So this is not the days to recovery after COVID diagnosis, but this is showing how age might be associated with days to recovery using this kind of scatter plot with a line that's a linear estimate of the association, which is just sort of plopped there. And you can see that as people get older, they tend to take longer to recover from COVID.
Josh, I know we're not meant to ask questions, but I can't help it. That line, Josh, is that real? That's looking at all these numbers, the blue dots, and it's saying how like they're closely aligned, because sometimes you do see these scatter plots and they draw a line to it and you go, really? Are the dots that up here, they sort of don't look like there's a line?
Would you say for this example that it doesn't look like there's a line?
No, it does. But, I mean, I guess there's those little ones up the top.
I think that what you're asking is, yeah, so this, I mean, I don't want to go too deep into the theory of regression, but in this case, I would say that this is roughly quite a linear association. So the line is a good estimate of the association. But in some situations, you do have what's known as a nonlinear association. And so it would be actually incorrect to be trying to use this kind of single straight line to estimate the relationship between the two variables. But it's quite a complex rabbit hole to go down. So maybe it would be good if I posted some maybe resources afterwards if people are interested.
No, it's a good point. So you have to analyze the data before you know how to present it.
I've seen a lot
Yeah,
of these,
and that's
Jackie,
actually-
a lot of these examples of people who try to fit lines when there is no line to be seen.
Yeah. Okay. So, okay, good. That's all I wanted to hear.
Yeah.
It
There's
does
a bunch
happen.
of different measures of when, of being able to determine when a linear fit is a good fit. And it has to do with the R square and these other statistics that Josh is talking about that we can get quite deeply into it. What a regression does is it tries to plot a line that minimizes that vertical distance that you're seeing between the point and the line. It minimizes the square sum of those. So there will always be points that aren't on the line, that are quite far away. The line is just representing something that's kind of in the middle. That minimizes the sum of those squared errors, and you get a measure of how good a fit the line actually is. But yeah, you're absolutely right that people completely abuse this and fit lines when there's no line to be seen.
I think it might be helpful, I might just jump in as well because Bianca's got a question. It might be helpful just to go back a step to something less complex, which is the chart on the left, which is a scatter plot. No, you're right, Josh. So Bianca's just asking about scatter plots and when are they helpful? And I think the first thing you need is two things that are collected as numbers on a scale that is endless. So for example, the classic one, Josh has got days and age, which is fine. But if you think about the best example is always height and weight. So you know height and weight are they're collected as numbers, and they are not round numbers, and they don't necessarily always start at 0. That's the first thing you need to start with, is 2 columns of data that are all numbers. A scatter plot is really helpful if your question is, say I've got column A and column B. I want to know, as column A goes up, so as the number gets bigger, what happens to column B? Does the number get bigger or smaller for that same person? So you can see the dots could be a person, and it's how their column A relates to their column B number. And when you want to understand that relationship, then a scatter plot is a really good way of doing this, because it plots in a field where someone's column A relates to their column B. And you get to see the intersection like on a map, like they call it, or like coordinates plots. So if you took my height and my weight and you plotted them in space against each other, then you would see where I sit, and then where the next person sits, and the next person sits, and then you start to establish a relationship on average. As column A changes, what happens to column B? That's what a scatter plot is.
Cool, thanks.
All right.
Thanks, Sarah. So yeah, scatter plot's a very powerful tool, but as everyone's pointed out, can be easily, I guess, I don't want to say abused, but they can be misunderstood or misrepresented. On the right, we've got a line chart. So this is a bit more of a straightforward figure compared with the scatter plot with the regression in it. But what we're doing here is we're just showing the number of clinic appointments by month. So it's just showing a trend over time, and it seems that the number of appointments booked in at this clinic is increasing by month. So it's a nice way of visualizing what's going on over time at this. We're going to do some tips and tricks now. So I'm going to start with a table. And so this table is, again, totally hypothetical data, but it's vaccine demand versus vaccine supply in a local public health unit. And one thing that for me, when I look at this table, I think that I can see that the vaccine demand is going up and vaccine supply is slightly going up. It's hard for me just looking at this table to get a sense of what they're looking like in relation to each other, or what the story is in terms of what's going on with each of these, with the demand and supply by month. So one kind of way that you might want to use data visualization to show this association between demand and supply is by just using this line chart, which has showing that the demand is massively spiking around June and supply has gone up a little, but it's sort of remained the same. So it's kind of created this disparity in terms of supply and demand. And so if we think about those 3 kind of lessons from the very first slide around, first of all, drawing the reader's attention to the relevant data. So here we've got demand and supply, telling a story, which is the story is that there's this disparity that's being created over time. and then creating a call to action. So for me, if I was looking at this and I was managing this public health unit, I would probably think that we need to do something to increase supply somehow to match the demand. So that's a simple example. And now I've just put in a slide so we can pause for Q&A because we have a lot of questions coming through in the chat.
Josh, Taffy's question, why are there many critics against pie charts? And he's also asked, he's curious about the colours to use in graphs. Are there any recommendations? But yeah, I must admit, I've heard you two talk about pie charts, Anna and Josh. And you don't love a pie chart. I love a pie chart.
I love a pie chart.
But I understand the pie chart has to equal 100.
Yeah.
It has to be, the things that you're measuring have to be independent. So that's the message. So what are the problems with pie charts?
You want to answer, Josh, or do you want me to be the enemy?
Well, maybe I'll talk about the sort of a kind of logistical issue that I find with pie charts, and then you can kind of go into a bit more of the theory side of it.
Yeah, or
first of all, pie charts, I wouldn't have shown the pie chart if I thought there was no use for them ever. Like, there's still value in pie charts. But I think, like, logistically, because they are such a simple chart that's just showing the breakdown, within a group. If you want to somehow illustrate breakdowns within 10 groups and you want to use pie charts, you're going to have to end up with 10 pie charts. And that can become messy and difficult to read. And if it's in a report, you just end up cycling through 10 pie charts and they start to lose meaning. And so I think logistically, pie charts, whilst good, if you've got like a clear breakdown that you want to show for a specific thing, that can be really powerful. But if you've got lots of different things, then you might want to start thinking about different ways of visualizing that data. So I think just being mindful of the fact that if you want to maximize the impact of a specific type of chart, then it's better to try and keep it simple and not overdo it and use it too many times. So that would be my kind of like practical advice in terms of using pie charts. But then there's also some sort of theoretical stuff. So I don't know if Anna or Mar want to talk about that.
So my observation is that humans are actually really bad at estimating the area, relative area of these pie-shaped portions, if you want. So it's a visualization that doesn't really add much to just presenting the percentages directly, for example, for each group. So I think that's where a lot of the criticism comes from, where you want to try to find the simplest possible way to present a given piece of information. And in this case, it's usually a table, right, with the different percentages that you can easily compare to each other. And humans are really good at comparing different numbers if it's only like 5 or 6 numbers, as Josh says. If the number becomes huge, it becomes very unwieldy. But also in a pie chart, it becomes really hard to see really small slivers of pie as well and see how they compare to each other. And because it's such a simple figure, it has been abused to death. So you can see all these pie charts that are made 3-dimensional and with gradients and with I don't know what, and that just makes it more and more and more difficult to see the actual message behind it, which is these differences in proportions. So I have used pie charts at some point because I think they look nicer than a table sometimes, but particularly for a presentation. Like if you're writing a report, it's a little bit different than if you're giving a visual presentation. I'm a very visual person, so it is something that I've used to highlight differences in percentages. I'm not one of these people that say never use them, but they're very rarely really add value, I guess, is the point. And I don't know if Anna wants to add anything else to that.
Yeah, I think it's about, do they actually tell the story any better than another way? The challenge I find with pie charts personally is I'm very unclear if I am supposed to look for the difference between groups in the pointy end of the triangle or the outer section of the triangle. So how do I tell the relative difference between the groups? Do I look at how much of the circumference they take up, or do I look at the angle in the middle as to what they represent? And because to me, there's 2 things going on, the difference in the angle and the difference in the proportion of the circumference, my brain cannot quickly work out what is the difference between these groups accurately. And I think people then use colors in pie charts to misrepresent the pie chart. So something might actually be a smaller slice, but they put it in a darker or a brighter color, and then it takes up the pie chart. And I think, oh, that's the biggest group. But if you actually have a look at the data, it's not. And then I can't tell what's going on with the pie chart.
Great. I'm feeling very manipulated right now. And
you should, Jackie, you should. Wait, you should.
That's not the word that we're looking for.
Yeah,
Guidance.
No, but
You've never looked at the angle?
no.
I've never even considered that the angle.
Right.
Yeah.
Fair enough.
So if you think about that exact same information represented in bars that are exactly the same width but different height, that's a lot easier to see the relative difference between the groups, right? Than in a pie where they all look very similar, or what Anna's saying is.
Yeah.
You know what Bianca's now thinking? Bianca's now thinking, you guys spend way too much time looking at charts and talking to each other about looking at charts and having a jolly good old time looking at charts and freaking weirdos.
I'm just thinking it's amazing it's never even occurred to me there's two ends of the slither.
Yeah, that's
right.
where my
So
brain goes, right? And but you're right, Bianca. This is actually a really important point as much as we joke, because what you produce and you think it says is not what the person reading it says. If you give me a pie chart, I am so distracted by the angle and the circumference that I cannot understand the message you are telling me. I don't get it. That doesn't mean it's for everybody, right? And you're trying to cater to your audience and as many people as possible. But if you end up with a whole bunch of me's reading your report, not good, right?
No,
Absolutely not.
We're just annoyed.
Anna, you made a point before about what do you think about the numbers on top of the bars? So I love the numbers because it means I don't really have to look at the bars.
Yep. Yeah, I was just wondering what other people thought.
How does everybody else feel about the numbers? I must admit, it's very interesting you say that about pie charts, Mara, and that we find it difficult to visualize,
area,
interpret the space. That's right. Yeah, because I find percentages there because it's always going to be 100. There's some interesting information here about colours that Anna has put in the chat, and I'm just going to just for the purpose of the recording find it. So Anna's just said there's lots of colour theory out there, and colours do tell a story with limited effort. And I think it's like when I go to the supermarket, I don't let the marketers tell me which type of spaghetti sauce I'm going to get. I make my own decision. So now I've got to start looking at the colours on bar charts and say, where do you think you want me to look? So using complementary colours, people know straight away two things. For example, if you use complement colours, people know straight away that two things are different. Very good. Taffy, what is the rule of thumb for deciding line versus bar graph?
Sorry, Jackie, before we move to that, can I ask something about color?
Yeah, go for it.
You also, there's colors depend on what kind of data you have as well. So if you have categorical data, you want the colors that represent each category to kind of be maximally distinctive to the human eye. And that relates to what Anna put there about equity, people that are colorblind, so that they can clearly see the difference between these things, and that the difference, you don't get confused about which one is which.
Yeah.
But if you have something that's continuous, you might want to use a gradient thing or a divergent bar, like something, I don't know, temperature from 0 to positive to negative. It's really helpful if you use these divergent charts of going to red and going to blue or things like that. So there's a really good site that I think Anna has used in the past that's called Color Brewer. And that one gives really, really good reference of these different types of, it's called qualitative is the categorical one, divergent, or what's the other one? I'll look it up in a second. Anyway, so so that's another important consideration. I as Anna said before, also you can be very misleading if you use colors with different amount of brightness or hue or different things like that. So all of these color scales that are very well established have been researched so that each color is kind of contains the same amount of brightness, hue, blah, blah. It's just different tones. And that is a very fair way of representing these things.
That's great. Thanks, Mar. Morris, you got a question?
Yeah, I just wanted to, in relation to things like, you know, we talked about the numbers on top of the bars and stuff. As a general principle or rule of thumb, when we're preparing this visual representation of our data, is it a good idea to just be kind of guided by clarity of interpretation and the clarity of, because some of the things that I'm hearing are suggesting, you know, or maybe it's just the kind of Machiavellian part of my brain thinking that we can sort of manipulate our presentation of data to tell a story that might not be immediately visible to other people. Is that what we should be thinking about when we're presenting our data, or should we be just, am I being naive to think it's just about getting over the data in the most clear and readable way that we can?
Who wants to take that one?
Anybody?
Well, I think it's kind of related to what you asked before, Jackie, right? We're making you feel like we're completely manipulating into seeing what we want you to see. And I think, as Anna explained it really nicely, I think that there's an element of both. So we want to teach you how to identify when you're being manipulated by other charts, and they're using these techniques in a way that's not fair or representative of what's actually there. But we also want to teach you to both not accidentally manipulate other people when you don't want to. So avoid using these differences in brightness or whatever when that's not part of the message that you're trying, that's not reflected in the data, I guess. But also carefully being able to use it to call attention, draw attention to specific things that are really important parts of the message that you see in the data and that you want to make it very easy for others to see as well. So it's a combination of everything. Where I think our point in doing this is teach you there is potential for manipulation, so make sure you do the right thing, I guess.
Back to Tafi's question about lines, line versus bar graph. So Anna's just put in here, lines are good for trends over time, bars are good for volume. Do you want to explain that? Is there another way of explaining volume? So
amount, yeah. So remember, if you think about a line chart, you look at the line, it's got no mass, it's got no body, it's got no weight when I look at it. So I don't understand how much there is. If you're trying to tell me about how much, I need a visual representation of something that takes up space, and that's what a bar chart does.
yeah.
A line is thin, you know, like twiggy. That's how I kind of think of it. So I don't get a sense of volume or mass or how much there is, but I do get a sense of how it's progressing through space. So how it's moving across that bottom axis, what we call the x-axis. Then I get a sense of movement. So if I need a sense of movement, I need a line. If I need a sense of mass, I need a bar chart.
That is very interesting. A couple of months ago, Josh, I think you presented some data, I can't remember what it was, and you put it in a line graph. And I couldn't actually articulate why I couldn't see the point in the line graph. I couldn't see what I wanted to see. And I didn't know how, I didn't have the words to be able to say that. So I just said, Josh, but what does that mean? And you sort of, Josh looked at me and went, Jackie, it's like number of phone calls to a clinic. You know, you can see they've gone up or whatever it was, but that's exactly what I wanted. I actually wanted to see the volume in that example. There you go.
You're calling out my figure, Jackie.
No, no.
I'll use some bars on the next one for you.
Gosh. Thank you. You do love a line graph, Josh. You do love a line graph. I've noticed this about you. And I must admit, I've realized hanging out with a line graph person, I love a bar graph. So, you know, we've all got to acknowledge what tickles. So we've just got some others. I think that's it. Very good.
Cool. All right, let's do a couple more storytelling tips and tricks. When I can get to the next slide. There we go. So how can size and color change the story? We've been talking about this a lot, I suppose, but this is on the left, we've got 4 clinics. This is, sorry, Jackie, no bars. This is appointments by month over time. I feel like when I look at this, it's not really telling much of a story. There's something that like massively stands out to me on the left, maybe to other people that it does. But once I changed the color so that the red was like this kind of bright red with lots of contrast, and I dulled the colors on the other 3 clinics, I feel like the story that it starts to tell, so first of all, it draws my attention to clinic 4. That's the first thing it does. And then it makes me kind of compare it to the other 3 where they're kind of following this similar trajectory of this slight increase by month, whereas clinic 4 has got this sharp drop in appointments over time. So I think that this is sort of telling a story, and potentially, depending on who you are, could be creating a call to action that clinic 4 might need a bit more support, a bit more staffing, or something like that. So this is how size and color can change a story. Next, we've got an example of proportions. Oh, sorry, no, we don't. We're doing how we can use identical data to tell 2 different stories. So this is the one on the left. This is called a marginal change. This is a little bit of a hard concept to kind of get your head around, but well, it's not too hard, but it's a little bit kind of complex. But the idea is that it's the difference between January and February in clinical appointments, and then it's the difference between February and March, and then the difference between March to April. So this is just, rather than being an absolute change or a cumulative change, this is just the difference between months. And so on the left-hand side, it's really clear that there's a big spike around March compared with the other months, and then it kind of goes back to being a similar marginal change. And so the story that this is telling to me is that March has got a big spike in people booking in appointments. If we go to the figure on the right, which is showing cumulative change, then it kind of gets absorbed, that spike kind of gets absorbed into the line, and it doesn't tell the story at all of there being a spike. In fact, it's not discernible at all. I had to double check that I got my graph right, but it's really hard to see. So it's, this is just 2 different ways of showing this, of using the same data and telling 2 totally different stories.
Josh, can I ask a really silly question?
Mm-hmm.
How do you work out the marginal change? I get the cumulative. So what's the, like when you're doing this in Excel, how do you?
I just created a new row. I just created a new row, and I just said the amount of people in February minus the number of people in January. So if there was like 100 people, and so if there's 100 people in Feb and then 90 people in Jan, it's 10 more people in February than in January.
Okay, thanks.
So occasionally this may actually go below 0 as well in the marginal change if you've got fewer people in subsequent months to the month before as well.
Yep.
And the marginal change is something that's used a lot in a lot of financial data and economic stuff. It's not used so much in health, but it can definitely tell like you can really change the story that you're telling.
Mm.
And Jackie, is this where you're asking why are you not using a bar graph?
Am I thinking that, Tarpy? I get that. I get the marginal change.
Cumulative, you might have wanted to use
cumulative, I'm wanting to see a little bit more detail now, Josh. I don't more, Josh.
Well, my concern is that if I'd used bars, then you wouldn't have been able to see the lesson, because it would have been 2 different parts.
The lesson. Yes, the lesson. I know we're all students, but you know. I've got a question that's not related to any of this. The the one that goes up, the Y, the X, the X, the Y, the X, the Y, axis. Yes.
Oh, you're asking.
So the one that goes up, the vertical one. How when you see a graph and they will like do 0 to 100 in one level, and then all of a sudden they go 100, 105, 100. That's obviously allowed. And you just, so could you not just start at 100, or do you always have to start at 0?
Well, I guess
Well,
that's sort of two questions, isn't it? The first one is, are you allowed to change the sort of linearity of the scale? Which you can in certain situations, like if you're using logs. But in other situations, it can completely manipulate the story that you're telling, and should be avoided.
That's what I'm beginning to realize, yes.
And I suppose it's really like up to you as the reader to be able to identify situations where it's being used inappropriately, and to be able to identify situations where it's been used for a good reason. I think most of the time when it's being used for a good reason, you'll find that the person who's created the figure clearly states how the scale was actually put together. Yeah. And if they forget to mention how it was put together, then they might be actually trying to be manipulative.
Okay.
And the second half of your question was around where it actually starts, and whether it has to start at 0. I think in general, it's a good idea to start from 0 where you can. I always do. I think it's probably fair to say, right? Anna and Mar, have you guys got any thoughts on that?
Rule of thumb is to start at 0, especially when you're using bar graphs, because then area is, as Anna explained, it's the area that you're looking at. If you're using a line graph, it's a little bit less strict. So you can cut off, it's called the axis. And you have to denote that in a certain way. Yeah, but yeah, what I think we'll talk a little bit more about that later.
Okay. Yeah, we do have an answer to that question in a visual way. All right, so next one. How can proportions change the story? I think this is something that maybe everyone's come across at some point, but I think it's a really important lesson to take away, which is on the left, we've got booked appointments by month, got some bars for Jackie, and this is 2 clinics. And you can see that clinic 2 clearly has a lot more bookings for every month. There's maybe a slight linear increase, or slight increase over time with clinic 2, and maybe a slight one with clinic 1. But the kind of story that this is telling me is that in general, there's a lot more appointments being booked in at clinic 2 than clinic 1. Now, if we think that if we take into account the size of the clinics and how much staffing they have and how much capacity they have to actually see patients and make bookings, and we use that, and we actually use that as a denominator for these numbers, and then we create the same chart, but in the second one on the right, we're doing it as a proportion, and it's a proportion of the overall capacity of each of these clinics, so the amount that they can actually book. If clinic 1 actually has a far lower capacity, then as a proportion of the overall capacity of the clinic, they're much more closer to being booked out than clinic 2. And so just by adding in that denominator and taking into account the actual capacity of clinics, you're telling 2 entirely different stories with the data, which I think is a really important thing to bear in mind in data visualization. Cool, so now we're gonna do a chart Q&A with Mar. So the purpose of this little exercise is that I've got 3 figures, and Mar is going to talk to the figures, and she's going to talk about what she likes about them, what she doesn't like, and then just do a little bit of graph theory and use some of her expertise to kind of evaluate the graphs that we're going to look at. So starting off, this is refugee intake into the USA between 2009 and 2018. Mar, when you first look at this figure, what do you think of the things that you like about it, dislike about it? What kind of pops out at you?
So one thing that is something we've been talking about is the use of colors. So there's a really intentional use of colors in the last 3 bars that immediately draws your attention to that one and makes you kind of look less at the other bars that are not filled in on the left. So immediately you can see that the story is told in those last 3 bars. I like that they don't overuse color. So there's basically 1 color used, yet it's really effective. I really like the use of the messaging to explain what it is that we're meant to be seeing in the differences between each of these bars. And the use of bolding also in those very short sentences explaining what's happening at the time that these things are being measured. So it makes it quite easy to see that there's been a really sharp decline in those last 3 years compared to what was going on before. Yeah, I think those are the things I like the most about it. Dislike, I think you can also use, omitting information can also draw your attention to the information that you're omitting. So when I look at this, I kind of think, oh, why is each bar represents 1 year, or what are all these bars between 2009 and 2016, right? I feel like it would have been much easier for the person looking at this if they had just written the years under each bar. It doesn't add anything, but it doesn't distract you to the fact that those numbers are missing, I guess. I think that's pretty much the only thing that I dislike about it. The rest, I think it's great.
I think there's some consensus in the chat around the labeling of the bars as well. I'm just trying to see if there's any other thoughts that people have. Feel free to post your own thoughts on these figures in the chat as well, and then we can talk about it.
You're also welcome to come off mute and jump in. You know us, we don't mind people coming off mute and talking.
Yeah, that's true. That too. Taffy said, why the full number of refugees? There's another fall after 2010.
Yeah, so with any process, there is variability, and the concept of noise is really important. This drives me crazy with people, with journalists analyzing COVID numbers and saying, oh, numbers went down today from 2 to 1. I'm like, that's not going down. You don't understand. Every day will be slightly different because these are complex processes, biological processes. They depend on a bunch of different factors. And so, and it's kind of related to what Jackie said before in the scatter plot. There's always variability around something. You're just looking at a general pattern, I guess. And so if you look, often what people will do is to plot lines or something, or to see these differences in trends, they'll average over a window around each point to see if actually something is actually a change relative to before, or if it's just noise or just normal variability that you would expect to see in these kind of things. There's no reason to expect the exact number of refugees to be exactly equal every single year. But you can see that in all the white filled bars, it is roughly stable. There are a little bit of ups and downs, but it is mostly stable, straight, plateaued. Whereas after, you can see a very sharp decrease. But yeah, it's also true that maybe 3 years is not enough to see a pattern here, and maybe you need more information to know what happened or not. But yeah, aligning it with certain events that happen that experts think would have an effect on these numbers, that makes the relationship a little bit more clear, I guess.
And it clearly looks like they're trying to show the impact of the Trump administration, particularly, hence why they're only explaining the decrease as a result of that, rather than they don't really care what happened in those other years.
Yeah. That's a
but
great point.
if there was something specific that made it go down a little bit in from 2010 to 2011, I think it wouldn't hurt if they added a little note there, like, oh, we think this is due to something, this change in policy or whatever.
Yeah.
Yeah, I think that's the caveat when you're trying to tell a story, and we also see a story in what you're trying to show. So your story is trying to say during the Trump administration, and we see that significant drop up to 2018. But I could also come in and analyze this chart and say, wait a minute, there was a drop in 2010 to 2011 to significant levels, appropriate levels, according to where I'm sitting. And that drop you see in 2018, 2017 was abnormal. Can I also spin and tell another story?
Taffy, I think I'll jump in because we've talked a lot about this, but we want to be a bit careful about language. And I don't think it's about spinning. It's about asking a different question. So I would kind of just be a bit more balanced about where we go with some of that language about spinning stories, because actually I don't think this is about spin. It's about what is the question and what is the story. And the question here is, what was the effect of a certain administration on refugee intake? And it's perfectly valid to just ask one question and answer one question with the data you have. I think if you have another question, which is what happened over time and what explains all of the changes in refugee intake, then you can present that and you can do that. So I think maybe we probably have overcooked this concept of manipulation and spinning things, and maybe let's just bring it back a little bit to, have they told you what is the clear question and have they answered that question? Yes, I think they have, and I think they've done that well. Are you allowed to ask another question of the data and present another answer? Yes, you are.
I would argue that that question could be clearer. Why the fall in the number of refugees during Trump's administration? Because it doesn't address the rise in refugee intake during Trump's administration as well. So I think that clarity is really important in the question as well as the answer.
Yeah, but they don't have to do that for you. Don't be lazy. You could ask yourself, what is the exact question? You know, like you can't just put it all on people to say, you didn't tell me. What we're teaching you is that you have to think for yourself as well. What is the question that this graph actually answers?
But that doesn't mean that you wouldn't, if you're writing a paper or a report, that you wouldn't address these other questions also in the text. It's just not the main point of it. So it doesn't necessarily need to be reflected in the figure itself. I'm sure if they wrote text about this, they would have something about what explains year-to-year variability in general. Yeah.
I'm going to move on. Thank you so much, everyone. These are great questions, and we can continue asking questions on the next slide. So this is average female height per country. I feel like there's a lot to unpack in this graph. So feel free to either for everyone in the call, feel free to contribute as much as you like. Mar, what pops out to you at the start when you first look at this?
Can I ask if Morris, Taffy, Melita, and Bianca see anything weird before I condition them?
Yeah.
I certainly don't like it. It's a lot going on. And I think the figures are disproportionate. They don't just get taller, they get wider. So it just, yeah.
So they're using area or bar charts, the equivalent of bar charts, which in this case is a human figure, to represent something that's not an area, right? Especially taking into account that the vertical axis doesn't start at 0. So why are their feet? Yeah, why are their feet in that vertical axis?
What Jackie was saying earlier, that visual representation of a woman, because it starts with her feet and ends with her head, suggests that that's ground level, the bottom axis, the x-axis. But when you look at the numbers on the left, it's not 0.
Exactly. It's like
it makes it look like
8.
Like Indian women are about a quarter of the height of Latvian women, which is
they go up to their knees.
Also questionable choice of color scheme as well, potentially.
Very pink.
And then just the use of icons. Does anyone have any thoughts on not even just as a sort of form of, this is a form of taste, I suppose. But anyone got any thoughts on using icons in place of bars? Jackie, you might have some thoughts on
Well,
that.
it just doesn't really work, does it? I'm also going back to the colour. I'm interested. The Latvian woman and the South African woman, are they related, like the Australian and the Peruvian women? Because they're and the Scottish and the Indian.
Yep, that's a great point. And then also what
100%.
Mar was saying earlier on gradients and the effects of gradients. It's not a very intuitive kind of, because they have kind of got similar shades of the same color. But if it were a gradient, it's not a very intuitive one. It goes from dark to light to dark to light to dark to light. So lots to unpack on this one, I think.
a lot to dislike about this one. I'm with Bianca.
The typeface for the title as well of average female height.
Yeah.
Kind of scribbly.
Yeah, what's going on with that?
It's like it's been done in kindergarten, or it's like it's done for a kind of kindy audience, you know what I mean? As opposed to...
Now, if this was a line chart instead of an area kind of bar chart, it would be perfectly fine to not start the axis at 0, right? Because then you're not comparing relative area. You're just seeing the trend over time. So that, I think this answers your previous question a little bit, Jackie. Or can you cut the axis off when it's not relevant? Yes, you can, if you want to focus on the difference between the points that you're showing.
Yeah, right.
Just not if you're representing it with bar graphs or area figures. Yeah.
All right, let's go to our last example. We're going to have Mar, just in 1 minute, if you can, explain what's going on with this graph before we move forward. We have 3 minutes left, so. Sure,
I'll speed it up. This is one of my favorite types of charts, which is called an alluvial graph. And it allows you to see, to visualize longitudinal data, which is kind of difficult to visualize in any other way, right? See how the same people that you're interviewing maybe every 3 months or whatever, how do they change over time? So this chart is showing how many people are on opioid substitution therapy. So it's a cohort of people that have been followed up over time. And some people drop off, and that's why the bars get smaller and smaller over time. Some people drop out of the study, but what you can really see is at any point in time. So at the beginning, they ask, have you ever been on opioid substitution therapy? That's the first bar. And maybe 3/4 of them have, and 1/4 of them hasn't. And then they go on to ask, are you on opioid substitution at different points of time during the follow-up of this cohort? So in the month before you went into prison, at any time during prison, at the baseline interview, which is after, right before they get released, at release, subsidy, retained, at 3-month post-interview, retained, at 12-month post-interview, etc. And the other really important thing is that you can see people when they go from, so these lines connecting the bars, you can think of it, each horizontal line represents one person. So you can see if they switched from one group to the other. So you can see quite a few switches between the 2nd and the 3rd, and between the 4th and the 5th. Between the 2nd and the 3rd, a bunch of people went from not being on opioid substitution therapy in the month before prison to being on opioid substitution therapy during prison. But overwhelmingly, you can see that people don't really switch between the groups a whole lot. So it's mostly the same people that have continued to be on opioid substitution therapy, and it's mostly the same people who have not been on opioid substitution therapy. And that's what those pink kind of shaded bits between the bars represent. So I love this kind of figure because I think it makes it quite easy to see things that you wouldn't be able to see if you were just doing a table.
Yeah, unfortunately, we don't have time for everyone to ask questions about this figure because we only have a minute left. But I think this is a good example of kind of taking in a few of those different tips and techniques that we've discussed and creating a simple, well, still kind of complex, but a nice figure that can tell a really good story using quite complex data. It's now 10:59, so if anyone has any final questions which you wanted to answer, feel free to post them in the chat and we can respond to them and send them through as an email.
Josh, for some reason, it's not letting me launch the poll. Are you able to do that? Just click on the poll. It's just saying I'm logged in from another device, which I have not been for the last 18 months. It's the same device. Thank you all very much. I will send out the slides to this group, and then the recording will be made available when Josh has time in the next couple of weeks to do all the cutting and the editing, and we'll send that to the broader group. A massive thank you to Mar for joining us today as a STEM superstar. Really, really grateful for your insights. And once again, massive thank you to Josh for a great communication of some very complicated concepts. So thank you all for coming, and we'll see you next time.
Thanks, everyone.
Thanks, everyone.